Okay, so for 13.1, we are going to start the exciting world of limits. We're going to find limits numerically and graphically today. And by the end of today, you're going to be able to estimate the value of a limit using tables and graphs. So we're going to explore this limit business by first using the Math is Fun website. And I put the link on there for you in case you wanted to visit that at home. As we go over the information on the website, you're going to fill in the important information below. So I'm going to give you a few seconds right now to read over those questions so you can tell what you're going to be looking for. Okay, so take the next 10 seconds to read over those questions. All right, did you guys all have enough time to read over those questions so you know exactly what you're going to be looking for when I read over that part? All right, so we are looking at an introduction to limits. So sometimes what happens is we can't work something out directly, but we can see what should happen as it gets closer and closer to a certain value. Okay, so limits are useful when we can't work out something directly, but we can see what happens as we do what? Get closer and closer to a certain value. So that should be something that you have written down on your note guide. Let's look at this example. So for x squared minus 1 over x minus 1, if we try to substitute in 1 to work that out, what happens is we end up with 0 over 0. 0 over 0 is a special case. We don't really know what the value is, so we say that it's an indeterminate value. Okay, so an indeterminate value would be what? What's the indeterminate value? 0 over 0. Okay, so that's your indeterminate value. So since we don't really know what the value is, we have to find another way to answer this. So instead of trying to plug in 1 and see what we get, we are going to approach it closer and closer. So for my input values, I'm plugging in values that are getting closer and closer to 1. And then if I look at my y values, it looks like my y values are getting closer and closer to what number? Closer and closer to 2. So now you can see that as x gets close to 1, your x squared minus 1 over x minus 1 gets close to 2. So now we have this interesting situation. When x equals 1, we don't know what the answer is. It's indeterminate. But we can see that it's going to be 2 because that's what it's getting closer and closer to. You want to say the answer is 2, but you can't. That's not mathematically correct. So instead, we're going to use that special word of a limit. Okay, so the limit of x squared minus 1 over x minus 1 as x approaches 1 is 2. And then this is how we write it with symbols. So on your sheet, it says a limit is written in symbols as, and then for that, I want you to write the limit. This is x goes to 1. It's a little arrow there. X goes to 1 of your function, which is x squared minus 1 over x minus 1, and that's going to equal 2. Now below that on your sheet, it says, what does this mean in words? So in words is what we discussed up here. So that's what I want you to write down. So what this means is the limit of x squared minus 1 over x minus 1 as x approaches 1 is 2. Okay, so in words it means the limit of x squared minus 1 over x minus 1 as x approaches 1 is 2. Okay, and another way you can think of this is it's saying, well, we're just going to ignore what happens when we get there, but as we get closer and closer, the answer gets closer and closer to 2. Okay, so we aren't worried about what actually happens at the exact value. What we want to know is what happens as we get closer. So if we look at this graphical representation, we can see there's a really, really small hole here. So that's going to happen when x is 1. Remember when we plugged in 1, we got 0 over 0. So this hole is going to occur at the indeterminate value. Bless you. Okay, so on your sheet it says, where does the hole in the graph occur? So for any graph, that hole is going to occur at the indeterminate value. Now, when you're graphing that on your calculator, oftentimes that hole is so small that you will not be able to pick it out because of the way your calculators are pixelated. Unless you have like one of the newer ones, you might be able to zoom in enough to see a tiny gap. But with like the 84 and the 83, if they're the bulkier ones that don't have the rechargeable battery, the pixels will not show you that hole. So if we have a hole in our graph, what we have to do is test the function from both directions, from the left side and from the right side. Okay, so that's something else that we have to write down on our chart. So it says, because of this hole, what must we make sure we do? We must test the function from both directions, the left and the right. Okay, so we have to test the function from both the left and the right directions. Right, so you can see this guy running up the hill, right, and then running down the hill. Sometimes it approaches a different value from the right as it does from the left. Now, the ones we've looked at so far today have both approached the same value from both sides. Okay? So with the example we just did, we looked at it from the left side, and now we're going to look at it from the right side. So as we get closer and closer to 1, again, we get closer and closer to 2. So that's also heading for 2, so we know that that limit is right. If you have two sides of the function and they do not approach the same value from both sides, this is when we say the limit does not exist. Okay, so if a limit does not approach the same value from both sides, we would say the limit does not exist. And here is an example of where a limit does not exist. So if you look at this first part of the graph, okay, coming from the left, you can see that it's approaching this number, 3.8. But on the right side, it's approaching what value? 1.3. Okay, so because they're approaching two different values, we would say that limit does not exist. One thing we can do is we can use one-sided limits, which are going to have some special symbols. And the special symbols you can see right here. So this says the limit as x goes to a with a little negative above the a. That's going to represent a limit that's approaching from the left side. Okay, so that's one of the symbols you'll want to write down. So you can write down limit, x goes to a with the negative exponent there. And what that means is you're finding the limit as it approaches from the left. Okay, so the limit as it approaches from the left. The other symbol is going to be the limit as x goes to a, and then see how you have the plus sign as your exponent? So what do we think that means? It's going to be what? If the negative's for the left, then the positive is for the right. Okay, so the limit as x approaches a to the positive means that you're going to find the limit approaching from the right. Okay, so that's going to be the limit approaching from the right. And you can see it tells you that here too. Okay, so 3.8 from the left, 1.3 from the right. So we're using that negative symbol as an exponent. We're using that plus symbol for the right side. Okay, and then the ordinary limit, which would just be with no symbol, does not exist. Now, all of the functions we've looked at so far have had an indeterminate value. You do not have to only use limits for a difficult function. For example, if you wanted to find the limit as x goes to 10 of x over 2, you could plug in 10, and 10 divided by 2 would be 5. Okay, we could still use limits if we want to, it's just they're not very useful in this case because you can solve it without a limit. Okay, so limits are most useful in cases where you have an indeterminate value. Now, infinity is something special. In your worksheet from yesterday, we just talked about how the last one approached negative infinity and positive infinity. Remember that infinity is an idea, so that is not a number. Okay, infinity is not a number. So if it's going towards infinity or negative infinity, the limit would not exist. Okay, so we don't know what that would be. Right, so the last thing that I want you to write down from this part is when you see the limit, you should think approaching. Okay, so when you have the limit symbol, what that means is you want to see what happens as it is approaching the value. Okay, so now what we're going to do is question 1. Okay, so on your sheet there's a little spot that says question 1. We're going to write this down. So it's the limit as x goes to 2 of x squared minus 4 over x minus 2. And then I'm going to give you a second to make sure you wrote down everything from that first part. Okay, if not, then you may want to look back over the video. And then we're also going to write down the definition of a limit in a second. Okay, so for question 1, we're going to do that together. So the question 1 says the limit as x goes to 2 of x squared minus 4 over x minus 2. And we have to figure out what that is. Okay, so the first method is going to be using a table. So on your table, what we're going to do is we're going to pick 3 values from the left, and we're going to pick 3 values from the right. Okay, now you can choose really whatever 3 values you want. but you do want them to get closer and closer to whatever your limit is. So see how for this one it says the limit goes to 2? Okay, so when I think of numbers that are close to 2, we might start with like 1.99, 1.9, maybe 1.5. So values that are close to 2, 2.001, 2.01, 2.02. Okay, and as we practice this many times today, you will get more comfortable with picking your own values. Okay, so what I want you to do is I want you to use your table on your graphing calculator to figure out what your y values are. So go ahead and do that. Alright, so then we're going to do x squared minus 4 divided by x minus 2. Okay, and then I like to find them using my table set because I can start that wherever I want. So if I start that at 1.5, I can see it's 3.5. Okay, I could also like make this go by 0.1 and it would take me to 0.9. So 1.9 is going to be 3.9. And because I went by 0.01, I can actually just scroll down. You can also use the value function in your graph if you prefer that. Are there any other ways you guys like to do this? Any other things that you used yesterday or no? Nobody's responding. How did you guys find your stuff from yesterday? Can't really guess and check. Okay, so remember, because of this, x goes to 2, I'm picking values that are close to 2. Okay, I don't want to actually evaluate at 2 because that's when you're going to get an indeterminate value. Now, according to my chart, it looks like I'm approaching what value? It looks like I'm approaching 4. Okay, so we would say the limit of this is equal to 4. Yay, we did our first limit by a table. Yay. Okay, so let's write a general definition for the limit. Okay, so if we have the limit of some value as x goes to a, f of x would equal L. Okay, and then the limit of f of x as x approaches a equals L is what it means. Okay, so a is going to be just different values, and then the L is going to be your limit. F of x is going to be your function. All right, and then let's go to example 1. For all of you listening in at home, Miss Whipple has a sore throat, and that's why I sound very nasally today. Okay, we are going to make a table of values as x approaches 2. Okay, so that's because of this. The limit as x goes to 2 tells us we're going to make a table of values as x approaches 2. We're going to find the value of the limit by making a table of values, and then we're going to check our work with a graph. Okay, we're going to use 3 values from the left, and we're going to use 3 values from the right. Okay, and this time I'm going to switch up my values a little bit. So from the left, maybe I'll use 1.99, 1.999, and 1.9999. Right, now again, you can use your table function for where you want to start. Okay, so then I know this would be 3.99. And I changed my table set to 0.001 so then I could just scroll down if I wanted. And some of these you're going to notice some really nice patterns, such as this one where you're just adding the 9 each time. And then here I have 4.001. I'm going to go to 2.001. Get 4.001. Okay, so according to my table, it looks like I'm getting closer and closer to what value? What does it look like I'm getting closer and closer to? Colin, what do you think? 4. All right, now it says to sketch a graph to check. Okay, we're just going to sketch what part of your graph is. And I'm going to use my table to plot some points from that. So if I have 0, 1, 2, 3, 4, and then 1, 2, 3, 4, 5. Why didn't you guys tell me I did that whole thing wrong? I never changed my value. I never changed my equation. Okay, so I didn't plug in my new equation, which is x squared plus x minus 6. Don't erase everything because it's actually going to be a simple fix. Okay, and then when I go back to my table, I'm just going to show you what's happening. See how we had all the 4s? This one is really going to be what? 5. See what's happening as I get closer and closer to 2? See how I have all those values there? So just change this. If you're watching the video, I'm sorry. I don't have time to do this again, so I hope you forgive me. Okay, now, like I said, there is going to be a hole, but it's going to be very, very small. When I go to my table, I am going to look at these values. So at 0, I'm at 3. At 1, I'm at 4. At 2, while there's an error, I know that's where my hole is going to be. Okay, and you're getting an error because that's where the hole is. Okay, so at x equals 2, we would have 0 over 0, which is indeterminate. Okay, and again, the way that you're finding these, when you plug in this value, you do have the 4s and the 5s. So I'm sorry if that confused you, if you plugged yours in the right way and didn't see that. And then your solution is going to be the limit as x goes to 2, x squared plus x minus 6 over x minus 2 is going to equal 5. Okay, now for example 2, we're going to complete a table of values. We're going to round to 5 decimal places and use the table to estimate the value of the limit. Now this one we have a trig function. So in order to graph this correctly, your calculator needs to be in radian mode. You guys know where that's from? Did you say G.I. Joe? No. Why don't you ask him? Alright, now this one, the value that x is approaching is 0. Okay, so you want numbers to the left and to the right of 0. So I could use 0.0001, 0.001, 0.01. And then on the other side of 0 are what kind of numbers? Negatives. Right? And then these are just some examples of different values that you could use for that. Now, this time I will make sure I go to my y equals and I will change it, since nobody in my second hour will help me when I make a mistake. Technically don't need that. Divided by x. Alright, and then I can go to my table set, or I can also go to my graph, which, do you guys remember what tangent functions look like? Your squiggles there. Oh, it's so beautiful. And then I can go to calc, value, and then if I wanted, I could just punch in my value for x, and then it would give me my value. So this is what we're going to round to 5 decimal places. So 90. Okay, if you're using your table, they might not give you all those decimal places. Let's look at what happens for 0.001. Okay, so for 0.001, if it's just 3, I'm going to do 3.00000. I'm going to use my value. Oops, enter. So this would be 1, 2, 3, 4. And on the 5th one, it would round up to a 1. And then for my next value, 0.0001, I'm rounding to 5 decimal places, so it'll be oops, too many zeros. And there you go. And then, like I said, you can also use your table. again, you get something like 3. Why do you think it's rounding it up to 3 for that? Yeah, it is. They're just rounding it because it's so small. So if you just had 3, you would just do 3.00000. For this one, you have 3.0001, and then you have 3.00090. And then see how that one just rounds to 4 decimal places, so I just put the 0 after that. Okay, so then we know, according to our graph, that this limit is going to be approaching what value? 3. Alright, now we're going to talk about the limit does not exist, so something we touched on earlier. So some functions do not approach a finite value at every point, and then when that happens, you say the limit does not exist. So not just something that you heard in Mean Girls. Limits that do not exist. Here are some examples. It's hard to see them, so I'm just going to highlight them for you. So see how these two are going to separate values? This is similar to one that we had on our sheet from yesterday. It says how many memes can you possibly look at in a day? Me, the limit does not exist. Okay, so in order for a limit to exist, it must approach the same value from the left and from the right. Okay, so that's important as we go to our next. So for example 3, we are going to use a graphing device to determine whether the limit exists. If it does, we're going to estimate the value to 2 decimal places, and we're going to include just a sketch of the graph and a table in our work. So let's go ahead and graph this, and then we'll draw a sketch of that. So go ahead and graph that on your graphing calculator. Alright, so once you put this in your graphing calculator, you are going to just draw a sketch of that. So you have 1 minus x divided by x minus 2 squared graph. Okay, so mine, it looks like it's above here and going down. It looks like it's right here. It looks like this is going to be an asymptote at 2. Right, and then I'm going to create my table. So we have a sketch of the graph. And sometimes I'll do like 2 separate tables, so I'll do one for the left and then one for the right. To the left, to the left. We need 3 values for the left side, so this one's approaching 2, which we've used a lot today. So here are some good values for us. Right, and remember you can either use your table or you can use the value on your graph to find out what these are. So for 1.9, I have negative 90. 1.99, I have negative 9,900. And finally, it says negative 1 e to the 6th. So if it's e to the 6th, what does that mean? There's 6 zeros, right? Okay, so it'd be negative 1 million. Alright, and then let's see what happens from the right side. Oh, I got that same thing again. Now don't be fooled just because you got that same thing again thinking that that's what it's going to approach. So think about our last few examples. Our last few examples, all of the values on the table were really, really close together. Are these values close together? No, they're how much apart? Well, not millions, but 990,000, right? It is, but we know it's not if one of them is a million. Okay, so for this, you can see that this is going to keep going down. Okay, so it's going to approach negative infinity. This side is going to keep going where? Up. Okay, so this side's going to keep going up. You can look too and see, oh look, both of these are going down to negative infinity. This side is coming up here. So this is going to be a case where the limit does not exist. So we would do the limit as x goes to 2 of 1 minus x over x minus 2 squared equals, it does equal negative infinity. Now even though they're both approaching negative infinity, remember how I said that infinity is not a number. Okay, it's not a fixed value. Infinity is an idea. That's not something that we can calculate. So the limit does not exist. Okay, so if you see that you're approaching infinity or negative infinity, we would say that the limit does not exist. Okay, again, because infinity is an idea and not a fixed value. Okay, and then we're going to graph B. Okay, so we have x cubed plus x squared plus 3x minus 5. Whoops. Divided by 2x squared minus 5x plus 3. And then we're going to take a look at our graph. Okay, so I'm going to draw a rough sketch of my graph here. Kind of looks like I have one of these going on. I am going to have an asymptote here. Okay, and then I'm going to pick some values from my table. So remember, when you do your table, you want 3 from the left, 3 from the right. So this is 1. So 0.999, 0.99, 0.9. And I could do 1.001, 1.01, 1.1. Okay, and I am just going to give you the values because I know we're getting to be about that time. me is nap time. Right, now these, if you look at these, and it's also helpful to look at your table and kind of see what's happening at those values. So when you're at like 0.999 and you're going up by like 0.001, you can see that it looks like you're getting closer and closer to what value? What does it look like you're getting closer and closer to here? What does it approach? Can we see how these are getting closer and closer to -8? Okay, so that means that our limit as x goes to 1 of x cubed plus x squared plus 3x minus 5 over 2x squared minus 5x plus 3 is equal to -8. Okay, so for your homework, you're going to do page 846, numbers 3 through 16, 22 through 28. Okay, and then I tell you which ones you have to write out the table of values for. For some of them, a table is given for you to fill out. And then for some of them, you can just use your graphing calculator. Okay, be good today. If I do not get to see your beautiful faces on this lovely day, we will continue 3.1 tomorrow. And remember, seniors, this is your last chapter. And underclassmen, we have chapter 13 and chapter 10 left. So stay focused, and I will see you all on Monday.